صباح الخير.
مونج احمد، يا ريت احمد ما تقفلش زي امبارح وتخلع. يعني
نعم.
خليك جنب الموبايل بس.
حاضر.
ماشي. Okay, let's start today. Yesterday we start to talk about Kepler law. Kepler produced many laws. The Kepler laws, as I told you yesterday, to explain the motion of planets in the universe or in the space. He produced 3 laws. The 3 laws have a state we talked about yesterday. The first law, which talk about the orbits around the sun. Planets rotate in elliptical orbit, not circular orbit. Elliptical orbit has 2 centers. So the first law, Kepler's law, the first law, each planet travel in elliptical orbits around the sun, and the sun is in one of the focal points. From this point, let's start to understand the difference between focal point and elliptical and circular path. How to draw elliptical and how to draw circle. We know that circle is easy by using compass, just one center, and rotate the compass to produce your circle. What about elliptic? Let's watch a small video to show how to draw elliptical shape. Okay. Okay, the following video is just to show you how to draw elliptical shape, and from the drawing you will know that elliptical shape must be drawn by 2 centers.
Ellipse 4, the pin and string method. I have 2 drawing pins pressed into the sheet and a string attached to them. To get the pins to grip, I have placed a piece of timber between the sheet of paper and the text square drawing board. The pins are located at the focal points of the ellipse. Start at one end of the major axis with the string taut and the pencil in contact with the paper. Draw the elliptical curve. This is a very smooth way of drawing an ellipse, but not suitable for an examination situation.
Okay, as you see here, to draw the elliptical shape, we use 2 centers and a string with a pen to draw this shape. Because of that, the elliptical shape have 2 centers, not 1 center as circle. And you cannot draw elliptical shape with 1 center, whatever happens. Okay, this is the first thing we need to see. Now go back for our PowerPoints. So the first Kepler law talk about the elliptical shape of the orbital of planet around Sun, and the Sun in one of the focal points. The second law talk about the imaginary line that connects between planet and Sun while the planet rotates. This imaginary line will cover equal area in equal time. For example, every day the area will cover equal, the line will cover equal area in the same time. We will show this by motion. Okay, the square of planet orbit period اللي هو periodic time of the planet in its orbit يسموه T square is proportional to the cube of the average distance, r cubic, between the planet and the sun. R is the radius of the orbit, or the distance between the orbit of the planet and the sun while it rotates. The cubic of R is proportional with the square of T capital, which is the periodic time. Okay, um, these laws developed after that by Newton's laws of universal gravitation. Okay, let me take you in a small video to understand also Kepler law.
The Copernican revolution, which placed the sun at the center of the solar system rather than the Earth, was a major event during the European Renaissance, a time when scientific thought truly began to flourish. In this climate, a figure like Danish astronomer Tycho Brahe was motivated to wield his status and wealth to build the most sophisticated instruments that had ever been built for the purpose of studying the heavens, and employ them to collect the best astronomical data yet collected at the time. Through meticulous observation of the planets and other objects, the Copernican model was corroborated much further, but the stage was set for further refinement of the model as well.
Okay, so he started here by the history of astronomy and each scientist what he did. Let's get to Kepler.
When Brahe's young assistant, Johannes Kepler, got his hands on this new data, he used it to determine that planets do not trace circles as they go around the sun. They trace ellipses.
Elliptical shape.
These shapes are discussed at great length in the algebra portion of my mathematics playlist. So if you want to know a lot about ellipses, click on this card now. But otherwise, it will be enough to simply understand that unlike a circle with its one center, an ellipse has two foci, and the sum of the distances from the foci to a particular point on the ellipse is a constant. When these foci get very close together, it starts to resemble a circle, since a circle is just an ellipse with foci that coincide. This is why the orbits of the planets seem circular, and why we operated under that assumption for so long. The brilliance of Kepler was to realize that the planets actually follow elliptical paths, with the sun acting as one focus of the ellipse. The point in a
As you see here, in the elliptical shape, the Earth will be one time close to the sun, and when it go the other side, it will be far from sun.
planet's orbit that is closest to the sun is called perihelion, and the point furthest away is called aphelion. The distances to these points are very close for most of the planets because the ellipses have very low eccentricity, but nevertheless, they are not circles. They are ellipses. This fact is the first of three laws known as Kepler's laws, which essentially marked the birth of celestial mechanics. The second of Kepler's laws says that the orbital speed.
Okay, so the first law of Kepler just talk about the elliptical orbit and the two center of this elliptical orbit, and this make the Earth part of its rotation away from the sun and part of rotation very close to sun. Okay, the second law
of a planet will vary according to its distance from the sun. It slows down when further away.
Yes, Mariam, you want to ask about something?
I didn't really get the part about the radius, that there are two radiuses and what they're equal.
Okay, okay, I'll try. I'll explain this again. Okay, so here, because the elliptical shape made by two center, the sun is one of the two center. So it is close to this part than closing to the other part. Okay, the elliptical shape is not just having two radius, is have a lot of radius because the distance from one center is different than the distance from the other center. So the other center is here when I point, and of course, because it's not circle, the distance between the Earth and Sun while it rotates is not going to be the same all the time, as you see here. In this case, as you see, the distance from the left side with the Earth is smaller than the other side because the Sun is at this center, not at this center. The Sun is not in the middle of the orbital. It is in one of the center, taking one side. عشان كده بيجي الجزء بتاع السمر بيبقى very hot, and when you go away it come to be very cold. Okay, Mariam?
Celestial mechanics.
Mariam, did I explain what you asked about?
Yes, I get it now.
Okay.
The second of Kepler's laws says that the orbital speed of a planet will vary according to its distance from the sun. It slows down when further away and speeds up when closer in.
This is a rule. لو انت ماسك, if you have a stone rotating with a thread, if you rotate the stone close to your hand with a small radius, you will find it's rotate very fast. But if you make the radius very long, the thread is very long, you will feel the stone is rotating slower. You can try it. تمسك حبل ورابط فيه طوبة، لو هي قريبة من ايدك وبتلف هتلاقيها بتلف بسرعة، لكن لو هي بعيدة بتبقى faster. سوري، بتبقى slower وهي بعيدة، قريبة بتبقى سريعة جدا. Okay.
A little more formally, it says that a planet will sweep out equal areas over equal time intervals. So if we take this...
Yes, if we draw a line between the sun and the planet, it's an imaginary line. When the Earth move here a small distance, the area it cover here must equal this area which happened in the same time. Let's explain this again by drawing.
Area A of the ellipse involving a part of the orbit that is closer to the sun, and this other equal area A of the ellipse involving a part of the orbit that is further away from the sun, the distances traveled by the planet, either C to D or M to N, in order to sweep out these areas are of different magnitudes. However, the planet moves faster when close and slower when far away, in a manner that results in precisely equivalent time intervals. And Kepler's third law states far away, in a manner that results in precisely equivalent time intervals.
Okay, this area produced in the same time this area produced. If we calculate this area mathematically, you will find it is the same as this area, because the Earth here rotates very fast and here rotates very slow. So in this time, it covered the same area. Let's go for Kepler's third law.
And Kepler's third law states that the amount of time a planet takes to orbit the sun, or its period, is related to the length of the semi-major axis. That's this length here, or half the major axis, which is the longer axis of the ellipse. Specifically, p squared is proportional to a cubed when measured in years and astronomical units, and the precise relationship will depend on the mass of the planet.
As we, of course, we use different sample, but it's the same. In the state of P, we use T, and in the state of A, We use r, so t square is proportional with r cubic. Okay, this is the third law of Kepler. Let's go back for our PowerPoint. Okay, Kepler is very long time ago before Newton, so Newton concluded his universal gravitational law from Kepler theory or Kepler laws. Newton demonstrated that Kepler law are the law of universal consistent with the law of universal gravitation. The fact that Kepler law closely matched observations give additional support to the Newton theory of gravitation. Kepler theory was dependent on observations totally or mostly, and this was a support for Newton theory because he concluded his theory by using Kepler's law. Okay, here, according to Kepler law, if the time a planet takes to travel the arc A, okay, is T1, the time it takes to cover the arc A2 is T2, okay. So it equals the time the planet takes to cover the arc by T2, then the area A is equal to area 2. If this time equal this time, this area will equal this area. This is according to second law. Thus, the planet travels faster when it is close. As I told you here, it will be fast. As I told you here, it will be slow. And Kepler third law state that t square proportional with r cubic, and the constant عشان احنا to remove the proportional to make it equal, you must have a constant instead of this sign. The constant which he used or he proposed is 4 pi square over gm, where m is the mass of the object being orbits. And if you talk about the Earth rotating around Sun, m is the mass of the Earth. يبقى هنا 4 pi square over g m, والg هو constant of Newton universal gravitational law. يبقى 4 pi square over gm تتحط هنا، يبقى t square equal 4 pi square over gm r cubic، ودي هتبقى الايكويشن. So Kepler's third law can also be stated at the following: t equal 2 pi، شلنا الار، شلنا السكوير ومش خلينا لي 2 بدل 4، وعملنا square root of r cubic over gm. خلاص؟ يبقى كانت الريليشن اساسا t square equal 4 pi square r cubic over gm. عملنا square root with two side بقت t equal بدل 4 pi square بقت 2 pi، وهنا دول square root of r cubic over gm. طيب الناس اللي لسه بتحضر متأخر يا جماعة، بعد كده أنا بعد 10 دقايق مش هدخل حد، هبقى أنا عامل ويتنج روم عشان كده. VT equal square root of GM over R. جابها منين؟ Okay, let's take the absent first and go back to the session. The absent here. Okay. Okay, let's start. Our day is 8. Session is the first. I am
Mister, did you admit Farah?
Yes. I don't have any person in the waiting room now. Okay, now the name of your class. Just a minute, let's open. The attendance. Okay, Rashwan, if you please, when I call your name, say yes. Rashwan, Matar?
Yes.
Yes. Bahroug? Bahroug?
Yes, sir.
Daniel?
Yes.
Jamal? Jamal?
مستر عمرو.
Yes, Rashwan. Somebody wake you
مستر
up.
هو أنا موجود؟ إيه؟
Somebody wake you up. Okay.
لا
Rashwan.
والله أنا صاحي من زمان بس أنا موبايلي 1%.
طيب ماشي. احنا كنا وصلنا لجمال. جمال. حامد. حامد. كريم. كريم. كريم again. Okay. محمد. كيكي. كيكي.
Here.
Okay. أبو الفرح. أبو الفرح. عمر. يا عمر.
يا مستر.
Okay. Peter.
Yes.
يوسف.
Yes.
بسنت.
Here.
فرح. Okay, Farah was talking with me because she had problem. She trying intern. Okay. Hania.
Here.
Jana Subh.
Yes.
Rujain.
موجودة.
Mariam.
Yes.
Maya.
موجودة.
Okay. Minnatullah.
Yes.
Mirna.
Here.
Nada.
Yes.
Salma. Salma. Summer.
Here يا مستر.
Okay. Shahd Ibrahim.
Yes.
Shahd Tamim. Shahd Tamim. Yauta. Yauta.
موجودة.
موجودة. Okay.
موجودة يا مستر.
Okay. Okay. Okay, getting back to the PowerPoint. Okay, how he concluded the relation, because as you know, speed equal distance over time. But to get the speed, I must put distance over time. The distance that the planet take around the sun is one complete circle, circumference, which is 2 by r. هيبقى 2 by r over t، يعني 2 by r هنا فهتتشال مع 2 by، والr هتخش تحت ب r square، يعني هتلاقي الريليشن كلها هتتقلب وهتتعكس. اوكي، فهيطلع عندك ال vt equal gm over r square root of gm over r. يبقى كل اللي عمله ان هو قال d over t وقال ان d 2 by r بس، وهيبقى هنا في 2 by r over كل ده، وهتطلع الريليشن بالمنظر ده. طيب this is a relation of third law, Kepler third law, وزي ما قلنا mass m is the mass of the central object that is being orbited. The mass of the planet or satellite that is in orbit doesn't affect. يبقى أنا لو بتكلم على القمر بيلف حوالين الأرض يبقى الام دي للأرض. لو بتكلم على أي planet rotate around the sun يبقى دي the sun. It's a center or a center object. Okay, these are some data of planets. For example, the mass of Earth and the radius of rotation, the distance from the sun. For each planet, they did the same. For example, the moon around Earth and radius, this is the mass and radius. These numbers could help me to solve the previous problem, could help me to calculate the periodic time or the velocity. Okay. This will be for tomorrow. We will start by this. It's a sample problem that we will answer tomorrow. This is everything for today. Thank you and goodbye.